Hi, this topic is going to show you how to apply the product rule of exponents when you have negative exponents involved. There's another video that will show you the product rule with positive exponents, so you can go search for that on my channel if you want. If you want to take it slow or you haven't seen that part yet, because it's probably better to start there if you haven't done it yet. All right, let's say that we have a problem like this. 4x to the 6 times 3x to the, I don't know, we'll say negative 10. The first thing is when I see a negative exponent, I'm thinking that I have to put it in the basement of the fraction. That's something that I've taught myself to learn, and it's how I teach my negative exponents to my students. Having said that, you're probably looking at this problem saying there is no fraction, so what are you talking about? So what you can immediately do is make it a fraction, right? If you put a fraction bar and stick a 1 underneath it, voila, you have a fraction now. So what did I just say about fractions? If there's something with a negative exponent, put it in the other part of the fraction. All right, so what in our original problem has a negative exponent? The only thing is the x. The 3 does not have a negative exponent, and that 3 is not attached to that x. It's just sitting next to it. So they can move around. All right, the x is the only thing that has a negative exponent. So we're going to put that in the basement. And the reason why we do that is we can now make it a positive exponent. That's how we handle negative exponents. The rest of it I am just going to write at the top of the fraction because that's where it was. Now we have to simplify. For everything in the top, it's multiplied across. There's no plussing, there's no subtracting. So we can rearrange it. And this is just what my brain is doing. You don't have to show this part of the work. I'm just rewriting the top. That's all. I'm putting the 4 next to the 3 because they are both numbers. And now it's really clear to me that I just need to multiply those because that's what this dot means. 4 times 3 is going to give me 12. X to the 6 still stays up there. Now I know I'm not done because I have x's in the top of my fraction and x's in the bottom. And I know that some of them can cancel. And again, this is what my brain is thinking. I have x to the 6. That is 1, 2, 3, 4, 5, 6. On the bottom, I have 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. If you're not scared to take 30 seconds out of your day and rewrite it like this, it saves you from having to memorize a ton of rules about exponents. I'm just taking this x to the 6 and expanding it. I took the x to the 10 and I'm expanding it. And that's going to help me not have to memorize what do I do with these rules. What do I do from here? Well, what I do is I start canceling out. So this pair of x's is going to cancel. This pair of x's is going to cancel. So I'm just canceling out 1x on the top with 1x on the bottom. Now I've suddenly run out of x's on the top. There's no more to cancel. So I have to still account for these in my answer. There's 4 x's there. That means I'm going to have an x to the 4 sitting in the bottom of my fraction. On the top, all I have now is a 12. So just breaking it down, this probably seemed like it went maybe a little long because I was talking a lot, but it was pretty simple. And honestly, we're going to do a couple more and we're just going to follow these same exact steps. All right, let's see what we got here. Let's try another one. Let's say that we have 2v to the negative 3 times 3v to the 7. All right, again, the first thing I look for is negative exponents. As soon as I see something that has a negative exponent, I'm going to move it to the other part of the fraction. All right, so my very first step is the 2 stays up here, the 3 stays up here, the v to the 7 stays up here, the other v goes downstairs and becomes a positive 3. Okay, now I'm going to multiply the 2 times 3. That's going to give me 6. The v to the 7 I'm going to write out. 4, 5, 6, 7. On the bottom I have 3. And again, once you do a couple, you're not going to need to write these out unless you want to be really sure each time. It's up to you. I still have my 6. How many v's do I have here? I have 4. And everything in the bottom canceled out completely. That doesn't mean there's a 0 there. Technically there's a 1, but we do not need to feel obligated to write it down. So either one of these is correct. You wouldn't be wrong with either. Leaving it either way. Okay. All right, you ready? I'm going to kick it up a notch. Don't get nervous. It's going to look gross for a minute, but we're going to do the same exact things that we were doing. All right, we have a 4x to the 9 v. Then we have times 7 u to the negative 4. We'll throw on an x to the negative 10, and then one more, 2v8. All right, first thing I'm going to do is just look for all those negative exponents, put those things into the basement. All right, so the 4 stays up top. Sorry. The x to the 9 stays up top. The plane v stays up top. The 7 stays up top. There's my first thing with a negative exponent. So I put it downstairs with a positive one. My x to the negative 10 has to come downstairs and be positive 10. Now I'm going to keep copying everything else. Now I'm ready to just clean up the top. What are my numbers, my coefficients? I have a 4 and a 7 and a 2. I have an x to the 9 that I'm going to put next. So I'm just making sure that I have all this. I have a v, a plain v, and a v to the 8. So I kind of crossed them out as I rewrote them, so I didn't leave any out. I wanted to make sure I accounted for them all. On the bottom, I'm not changing anything. I'm just copying. All right. So now at the top, I have 3 coefficients that need to be multiplied. All right. 4 times 7, that's going to give me 28. And then 28, if I multiply that by 2, I am going to get 56. The x to the 9 does not change. And here I have 1 v joining 8 v's. And the best way to write that simplified is to just put v to the 9. If I have 1 joining 8, there's 9 altogether. On the bottom, I still have a u to the 4 and an x to the 10. So I'm almost done. I know I'm not done because I have x's in the bottom and I have x's in the top. So I need to figure out how to cancel them out. And again, if you're kind of new at this or you want to be sure you're right, 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. On the bottom, I'm going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And my u to the 4 hangs out up there. All right, so now I'm going to cancel out. So I have an x canceling with an x, and then another pair, and another pair, and another pair. And again, it might seem tedious, but boy, it's hard to mess up if you're doing it this method. I'm just saying. So we're left with the 56 on the top, and a v to the 9. On the bottom, we still have that u to the 4 hanging in there, and we still have one x left. So we just need to make sure that we have that accounted for. Again, same steps. Take care of the negative exponents by making it a fraction. Clean up the top, clean up the bottom, and then look to see what else can be canceled. All right, let's do another gross one like that. All right, let's see. Let's say that we have, excuse me, we'll do 2y to the negative 9 times 2u to the negative 2. We'll add on an x, negative 6, and a u, and then times 7y x to the, I don't know, how about 9? Okay, so let's look for our negative exponents and put all those in the basement. So we're just going to go from left to right. The 2 does not have a negative exponent. The y to the 9 does. The next 2 does not have a negative exponent. The u to 2, the negative 2 does. Let's see, the next thing is x to the negative 6. That's going to go in the basement with a positive exponent. We have a plain u. Don't forget that. It's just sitting there, easy to miss, but you got to include it. The 7 does not have a negative exponent. The y does not have a negative exponent. The x to the 9. All right, so we've taken care of all the negative exponents. Now we're just going to clean up the top. 2 times 2 is 4 times 7. 4 times 7 gives us 28. I have a u, I have a y, I have an x to the 9. On the bottom, I have a u. I'm just going to put it in a different order so that it matches above. I have a u squared. I have a y to the 9, and I have an x to the 6. Again, it's going to be hard to get it wrong if I write it out. U, y, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, you do not need to do this. Just showing it. We have 2 u's. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 1, 2, 3, 4, 5, 6. I'm going to grab a different color just because it makes it a little bit clearer. All right, so for u's, we have a u canceling, so we still are going to have a u in the basement. 28 has not gone anywhere. For our y's, we have, I'm going to circle that, we have 1, 1 y. That's it. So how many do we have left? 1, 2, 3, 4, 5, 6, 7, 8. Again, if you know your rules of exponents or you remembered them, you know you subtract, the exponents. That's what most textbooks or videos, they want you to memorize, but we'll just keep it like that. We've done all our y's, so those are our leftovers. Last up, we have to do x's, so that, and then 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 that. And so we have 1, 2, looks like we have 3 x's in the top, so we need to keep 3 x's in the top. So again, my last part of the problem is canceling out, and wherever the remainders are, that's where we keep them. These y's, the remainder was in the bottom, so we kept the y's in the bottom. This u was left over in the bottom, we kept it in the bottom. These x's were left over in the top, so we kept them in the top. That's it. I know I'm done. I only have a 28. There's no other numbers to play with it. Excuse me. No other coefficients. We have x's in the top, but none in the bottom. We have u's and y's in the bottom, and no u's and y's in the top. So I know I'm completely done, and best of all, I have no negative exponents. All right, thanks for watching.